Good morning to everyone. Myself T. Muthukumar, Assistant Professor, Kongunadu College of Engineering and Technology. Today, I am going to deliver a lecture on switching and power frequency over voltages in power systems. So, in high voltage engineering subject. So, first we are going to discuss switching surges and its over voltages. Next, we are going to discuss power frequency over voltages in power system. So, switching surges for high voltage transmission lines, for example, so for transmission voltage 400 kV and above, the over voltages is generated due to switching of electric circuits. So this is switching surges is magnitude of the switching surges, so is almost similar to the or almost equal to the lightning over voltages. So it is happen in 400 kV and above transmission voltages. So this generated switching surges so may be available or maybe exist in the our power system during long duration means, so it is very dangerous to the power system. So we need to control this switching surges or to limit this switching surges value in the permissible level. So also if the system voltage is increases means automatically switching over voltage will be increases. So in other point, so switching surges plays a very important role for determining the insulation level of the transmission line and other dimensions and also cost. So next we are going to discuss origin of the switching devices surges. The main reason is the making and breaking of electric circuit with the switch gears. So this produce the abnormal over voltage in the power system. So the transmission line may be having the large inductance and capacitance. So making of and breaking of electric circuits with switch gears. So this is the origin of the switching surges. So this voltage is 6 times the normal power frequency voltage. Compared to the normal power frequency voltage is 6 times higher. So it is maybe available in the system for long duration means it is dangerous to the system. So in circuit breaking operation, switching surges with high rate of rise of voltages may be cause repeater restricting of the arc between the contact of a circuit breaker. So this may cause the circuit breaker contact may be damaged. That is the damage of circuit breaker contacts. So characteristics of switching surges. So wave shapes of the switching surges are quite different and maybe have more number of origins or sources. The following sources are the main reason for the switching surges: de-energization of transmission lines, cables, shunt capacitors, etc. Disconnection of unloaded transformers, reactors, etc. Energization or closing of reclosing of transmission lines and reactive loads. Sudden switching off of loads. Short circuits and fault clearances. Resonance phenomenon like ferro resonance, arcing grounds. So these are the origin of the switching surges. So if you energizing the transmission line, cables and capacitors, switching surges will be produced. Disconnection of unloaded transformer also one of the reason for the switching surges. Energization and reclosing of the reactive loads also reason. Sudden switch off of loads, if you suddenly switch off heavy load means automatically switching surges will be increases. Some short circuit conditions and fault occurrence conditions also switching surges will be increases. So ferro resonance phenomenon also one of the reason for the switching surges. So switching over voltages in EHV and UHV system, that is extra high voltage and ultra high voltage system. So switching surges will be generated in this ultra high voltage and extra high voltage system. So when there is a sudden release of stored internal energy, will be released in the form of electrostatic or electromagnetic form. So power switching over voltage will be induced. So Already stored energy will be suddenly released in the form of electrostatic or electromagnetic form, means the switching surges will be induced. So there are different situations are available. So interruption of low inductive currents by high speed circuit breaker. If you use the high speed circuit breakers, so interruption of low inductive currents will be happen. So that will be one of the reason for the switching over voltage. So second one is interruption of small capacitive currents, such as switching off of unloaded lines. If you switch off the unloaded lines, means so some interruption of small capacitive current will be happen. So this induces the over voltages, that is switching over voltages in the system. So next one is ferro resonant conditions. So this may occur when poles of a circuit breaker do not close simultaneously. So circuit breaker pole should be closes simultaneously. It is not possible, means automatically some ferro resonance conditions will be happen. This cause the switching over voltage. So last one is energization of long EHV and UHV lines. So if you energize long transmission line in EHV and extra EHV and UHV lines, means automatically switching surges will be increased. So interruption of low inductive currents, interruption of small capacitive currents, ferro resonance conditions. So energization of long UHV and EHV lines, these are the reason for the switching over voltage in extra high voltage and ultra high voltage system. So this generated high voltages, or that is switching over voltages in the order of 3.3 per unit. So per unit level, so it is a 2 to 3.3 level. So it has the magnitude of 1200 kV and 2000 kV on 750 kilowatt system. If you take in the 750 kilowatt system, the switching over voltage level in the range of 1200 kV to 2000 kV. In terms of per unit, 2 to 3.3. So the duration of this over voltages varies from 1 to 10 milliseconds depending upon the circuit parameters. So sometimes over voltages may last some several cycles. So generally the duration is 1 to 10 milliseconds. So in other case, other situations of switching surges that give rising to the over voltages, so shorter duration also possible. So the duration of this switching surges is 0.5 to 5 milliseconds. So generally 1 to milliseconds. There is another one is shorter duration switching surges. Time duration is 0.5 to 5 milliseconds and the magnitude is 2 to 2.5 per unit. Okay. So the somewhat magnitude level will be low for the shorter duration switching surges compared to previous one. So the reason for the origin of these shorter duration switching surges in extra high voltage and UHV system are single pole closing of circuit breaker, interruption of fault current when line to ground or line to line fault is cleared, resistance switching used in circuit breaker. If you use a resistance switching concept in circuit breaker, means this will happen. Switching lines terminated by transformer. So switching lines will be terminated by transformer, one of the reason. Series capacitor compensator lines, sparking of the surge diverter located at the receiving end of the line to limit the lightning over voltage. If we are to limit the lightning voltage, we are going to use a surging diverter at the receiving end. So sparking of the surging diverter will be happen. So this is one of the reason for the short duration switching surges. So single pole closing of circuit breaker, interruption of fault clearing when line to ground or line to line fault is cleared conditions, resistance switching one of the reason, switching line terminated by transformers one of the reason, raising series capacitor compensator lines one of the reason. So sparking of the surging divert at the end of the transmission, receiving end of the transmission line. So our aim are necessary to maintain the switching over voltage within the control. So the limit of the switching over voltage for a safe value less than 2.5 per unit, preferably 2 to 2.5 or even less is very comfortable or very safe zone for our power system. So we already discussed in long duration switching surges, the range is 2 to 3.3 per unit. Short duration 2 to 2.5. So we need to maintain the switching surges or control the switching surges value less than 2.5. This is very safe for the power system. So measures taken to control to reduce the over voltage. So what are the steps we are going to take or we need to take to control the reduce the over voltage? That is first one is one step or multi-step energization of line by pre-insertional resistors. So with the help of resistor, we are going to energize the system one step or multi-step at the starting time. So second one is phase controlled closing of circuit breaker with proper sensor. So with the help of the sensor system, we need to close the closing the phase or poles of the circuit breaker simultaneously. So drainage or trapped charges on the transmission line before reclosing the lines. So already some charges available in the transmission line means we need to trap these charges. Then only we are at the time of reclosing switching surges is not possible. So limiting the over voltages by using surge divers. With the help of surge diverters also we are going to limit this over. So these are the measures to be taken to reduce the over voltages in the power system. Next, control of over voltages due to switching. So what are the methods are available? So already discussed previous slide. So this is the control methods. Energization of transmission line in one or more steps by inserting the resistance and withdrawing them afterwards. So at the time of switching only, we are going to insert the resistor. After a few milliseconds, we are going to withdraw this resistor. Otherwise, over voltage will be increases higher. Second one is phase controlled closing of circuit breaker. So we need to simultaneously close the phase of the circuit breakers with the help of sensor system. Drainage or trapped charges before reclosing. Use of shunt reactors. Limiting switching surges by suitable surge diverters. So these are the methods to control the over voltages, that is switching over voltages. So first one is insertion of resistor. This is a common method for practice to insert the resistor or in series with the circuit breaker conduct. So we are going to insert the resistors in series with the circuit breaker conduct when switching on. But short circuit them after few cycles. After few milliseconds, we are going to short circuit this resistor. So this reduces the transient occurring due to switching. So with the help of this insertion of resistor during the switching time, so we are going to be able to reduce the transients occurring in the during the switching. So pre-insertion of suitable value resistor is in practice is done to limit the over voltages less than 2 to 2.5 per unit. So our permissible level is less than 2.5. So with the help of this pre-insertion of resistor, we are going to limit the over voltages less than 2 to 2.5 per unit. So normal time of insertion is 6 to 10 milliseconds. So this is the resistor insertion period. After that, we are going to short circuit or withdraw this resistor. So this is one of the method to reduce the switching over voltage or limit the switching over voltage. Second one is phase control switches. So over voltages can be avoided by controlling the exact instances of the closing of the three phases separately. So we are going to control the exact instances of the circuit breaker phases separately. So with the help of this operation, so we are able to limit the switching surges. But this is the complicated operation, including the complicated controlling equipment. Therefore, it is not adapted. So third one is a drainage and trapped charges. So when the lines are suddenly switch off, so electric charge may be left in the transmission line or in capacitors. So these charges cannot be removed before the reclosing of the switches means induces the over voltage. So these charges normally leak through the leakage path of the insulator. So this will be leaked through the insulator path. So this charges will be removed with the help of the conventional potential transformer So also we are going to insert the resistor or shunt reactor during the switching ons. So this trapped charges are removed by temporary insertion of resistor. Temporarily, we are going to insert the resistor or shunt reactor and removing the before the closing of the switches. Before closing of the switches, we are going to trap all the charges in the transmission lines or capacitors with the help of conventional potential transformer or temporary insertion of the resistor or shunt reactor. We are able to remove the drained charges. So after that, we are going to reclose, means there is no possible to generate the switching over voltages. So next one is the shunt reactors. So normally in EHV lines, we'll have the shunt reactor to limit the voltage range due to Faraday effect. So we are using the to limit the over voltage due to Faraday effect for the purpose shunt reactor we are using. So this also provides the switching over voltage when sudden energizing. So it protect the system during the sudden energization of the system. So this shunt reactor cannot trap all the charges, but it will give the oscillations in the system. Capacitance of the system will give the oscillations. So if you, the compensation is less than 100% means the frequency of oscillation will be less than power frequency over voltage, and over voltage produced may be high 1.2 per unit. So resistors in series with these reactors will suppress the oscillations and limit the over voltage. So already mentioned that they cannot drop all the charges, but give the oscillations in the system. So this oscillation can be removed by connecting the resistors in series with the shunt reactor. This will suppress the oscillations and reduces the over voltage. So these are the different methods to control the switching over voltage. So we are going to insert the resistance during the shunting. Phase control circuit breaker we are using, and drainage of trapped charges before reclosing, and also we are using the shunt reactor. So these are the methods to reduce the switching surges. So next time I'm going to discuss power frequency over voltages. So power frequency over voltages occurs in large power systems. That is, for example, especially in EHV system, 400 kV and above. And this over voltage is above the power normal operating frequency. So it is called power frequency over voltages. The main reason for the or main causes for the power frequency and its harmonic over voltages are sudden loss of loads. So immediately load will be losses, means automatically some voltage will be increases in the system. So second one is the disconnection of inductive loads or connection of capacitive loads. So during the operation of addition of capacity load or reduction of inductive loads, we are going to unfortunately over voltages will be increased in the system. So third one is the Faraday effect. So if you use the uncompensated long transmission lines, means secondary that is receiving end voltage will be higher than the sending voltage. This is called Faraday effect. So the voltage will be increased at the receiving end due to the Faraday effect. This is one of the reason for the power frequency over voltage. So next is unsymmetrical faults, saturation of transformers, tap changing operations of the transformers. So these are the main causes for the power frequency over voltage: sudden loss of loads, disconnection of inductive loads or connection of capacitive loads, Faraday effect, unsymmetrical faults, saturation in transformers, tap changing operations. So next we will discuss one by one elaborately. So sudden loss of loads. So if the load is rejected or suddenly removed from the prime mover side or generator side, means automatically the generator prime mover speed will be increased. So due to the increase in the speed, automatically voltage will be increased. But in our generating system, they have the speed governors and automatic voltage regulator will restore the normal conditions. But initially, both frequency and voltage increases. So when the load is rejected or suddenly released from our side means, so automatically prime mover speed will be increased initially. After that, speed governors or automatic voltage regulator regulates the speed and also the voltage. But initially, some frequency and the voltage will be rises. The approximate voltage rise is neglecting the losses. We express as V is equal to F divided by F naught E dash into 1 minus F divided by F naught XS by XC. So in this, F is called instantaneous increased frequency. F naught is the normal frequency. So E dash is the voltage generated. Excess reactance of the generated. XC capacitive reactance of the line. So load is released means automatically initially frequency and voltage will be increased. After that, it will be stabilized. So next one is disconnection of inductive loads or connection of capacitive loads. So we are going to improve the voltage transmission levels in transmission lines. We are going to disconnect the inductive load and we are going to add the capacitive load. So this disconnection or insertion of or connection of capacitive loads provides the switching operations. So during this, due to these switching operations, power frequency over voltages may be occur. So next one is Ferranti effect. So uncompensated long transmission lines exhibit the voltage rise at the receiving end. So if you use the uncompensated long transmission lines means, so automatically due to the Ferranti effect, the receiving end voltage is greater than the sending end voltage. So in long transmission lines and cables, receiving end voltage is greater than the sending end voltage during the light load or no load operation. So no load conditions or light load conditions. So receiving end voltage is higher than the sending end voltage. This is called Ferranti effect. So this is one of the major reason for the power frequency over voltage. The receiving end voltage V2 is equal to V1 divided by cos beta L. V1 is called sending end voltage. Beta is called phase constant of the line. L is called length of the line. So unsymmetrical faults. Single line to ground faults cause rise in voltages in other healthy phases. So if line to ground fault occur in any one of the phase means, so it will be affect the other phases also. So usually with a solidly grounded system, the increase in voltage, that is the phase to ground, will be less than the line to line voltage. So this is happen in the solidly grounded system. This is the normal. So phase to ground value will be less than the line to line value. So when effectively grounded system, x0 by x1 less than or equal to 3.3 and r0 by x1 is less than or equal to 1. So x0 by x1 less than or is equal to 3. Similarly, r0 by x1 less than or equal to 1. So here r0 and x0 is called zero sequence resistance and reactance. X1 is the positive sequence reactance of the system. Positive sequence reactance of the system. The rise in voltage of the healthy phases does not usually exceed 1.4 per unit. So if due to the fault condition, over voltage is increased, so they should not exceed 1.4 per unit. Otherwise, it is affect the other phases. So next one is saturation effects. So we are using the transformers for the transmission and the distribution systems. So when the voltages above the rated value are applied to the transformer, so if you apply the above rated value to the transformer, the magnetizing current increase very rapidly. So and maybe about full rated current for 50% over voltage. So if the magnetizing current is increased rapidly means it will be produce the 50% over voltage. These magnetizing current are of a peaky waveform. This is the peaky waveform. So because the rapidly increases the value. The third, fifth, and seventh harmonic content may be exist to 65%, 35%, and 25% of the exiting current of the fundamental frequency corresponding to over voltage of 1.2 per unit. So third, fifth, and seventh harmonic content with the percentage of 65, 35, and 25% of the exchanging current will be generated. For higher harmonics, serious resonance occurs between the transformer inductance and the line capacitance, which produces the over voltage. So if the harmonic is higher, means higher harmonic level means serious resonance occurs between the transformer inductance and the line capacitance, which produces the over voltage. So last one, tap changing operations. So tap changing operation occurs when the voltages changes due to the load variations. So if the load varied, means we are going to we are recording the tap changing operations. So during these operation, power frequency voltage occurs. So during the tap changing operation, power frequency over voltage will be occur. So finally, I'm going to conclude this session with the help of with the recall. So we are discussing two types of over voltages. One is switching over voltages, another one is power frequency over voltage. So switching over voltages, the origin is the making and breaking of electric circuit with the switches. This is the major reason for the switching surges. This is the 6 times normal power frequency within the voltage. So dangerous to the system. We need to control this switching surges. The reason or origin or de-energization of the transmission line, cables and the capacitors, disconnection of unloaded transformers, reactors, energization or reclosing of lines and reactive loads, sudden switching off of loads, short circuits and fault clearance, resonance phenomenon. These are the sources or origin of the switching surges. So next, control of over voltage due to switching. So energization of transmission lines in one or more steps by inserting the resistance. So we are going to insert the resistor in series with the circuit breaker contact at the time of switching. That is for few milliseconds. After few milliseconds, it will be short circuited. With the help of this arrangement, we are able to reduce the over voltage. So second one is phase control closing switches. We are going to close the exact instance of the 3 phases simultaneously of the circuit breaker. Drainage of trapped charges. The help of normal power frequency potential transformer or free insertion of resistor and such shunt reactors. So we are able to drainage the trapped charges available in the transmission line and capacitors before reclosing. So use of shunt reactors. Normally, shunt reactors is to reduce the Faraday effect in the receiving and transmission lines. So this also provides the switching over voltage production. So next one is power frequency over voltages. So the reasons are sudden loss of loads. So if the load will be losses suddenly, means automatically generator prime mover will speeds up. So prime mover speed will be increased, means at the time initially frequency and voltage will be varied. They will be increased. So after some time it will be stabilized. So at the initial condition, the voltage and frequency will be increased. So disconnection of induction load for improving the voltage transmission in transmission lines. So we are going to disconnect the inductive load and also adding the capacity load during this operation. During this switching operation, power frequency over voltage will be increased. So next one is Faraday effect. If you use the uncompatible long transmission lines, means receiving end voltage will be higher than the sending end voltage. So this is called Faraday effect. This is one of the reasons for the power frequency over voltage. So next one is unsymmetrical faults. So if any fault occur in any one of the phase, mean this will be affect the other phases also. So they should be less than 1.4 per unit. So saturation in transformers. So if you apply the above rated value to the transformer, so magnetizing current will be increases rapidly. So due to this increase in magnetizing current, 50% of over voltage will be increased. So this is one of the reasons. So next one is during the load variations, we required for the tap changing operations. So with the help of this tap changing operation, so we are not able to control the over voltage. So small over voltage will be induced during the tap changing operation. So these are the power frequency over voltages main causes. So our if you run the or operate the power system in safely means we need to control or limit the switching over voltage and power frequency over voltage. So switching over voltage should be less than 2.5 per unit. This frequency power frequency over voltage should be 1.4 per unit. So finally, I am going to conclude the session. Thank you very much.